Hi there, and welcome to the world of electrical resistance and resistors. In this video, we will explore some important concepts in electronics: resistance, resistivity, resistors, and resistor tolerance. These are key ideas to understand how electrical circuits work, whether in a simple light bulb or a complex computer. By the end of this video, you'll have a good understanding of how resistance and resistors control the flow of electricity, keeping your devices working as they should. Resistance is a measure of how much an object opposes the flow of electric current. In simple terms, it's like a barrier that slows down the movement of electricity. Every material has some level of resistance, but certain materials, like metals, have lower resistance, making them good conductors of electricity. When electric current flows through a material, the material's resistance causes some energy to turn into heat. This is why some devices, like light bulbs, get warm when they're on. Resistance is measured in a unit called ohms, whose symbol is the Greek letter omega. If a material has high resistance, it will allow only a small amount of current to pass through. If it has low resistance, more current can flow. While resistance tells us how much a specific object resists the current, resistivity is a property of the material itself. Resistivity measures how much a material resists electric current based on its nature, not its size or shape. For example, copper has a low resistivity, making it a good choice for wires. Rubber, on the other hand, has a high resistivity and is often used as an insulator to prevent electric current from escaping. Resistivity is measured in ohm per meters. This reflects how resistance changes based on the material's length and area. For practical applications, however, resistivity is often measured in square millimeters per meter. This unit is easier for engineers to work with because it considers the section of the materials used in electronics. Resistive elements are vital in electronic circuits because they control the amount of current flowing through the circuit. In this way, resistive elements help prevent circuits from overheating or damaging other components. For example, we have resistance in light bulbs, heating devices, or voltage dividers. In light bulbs, the high-resistance filament heats up and glows when current passes through it. In devices like toasters and electric heaters, resistive elements are used to generate heat, and in many circuits, resistive elements divide voltage so that certain parts of the circuit receive the right amount of electricity. Without these elements, devices would not function safely or reliably, and components would be more likely to overheat or burn out. The common electronic component specifically designed to add resistance to a circuit is called resistor. Resistors are made from materials with high resistivity, often a type of ceramic or carbon, which allows them to limit the flow of current effectively. They are one of the most basic yet essential parts of electronic circuits. Resistors come in different shapes and sizes, but most are small, cylindrical components with colored rings around them. These rings indicate the resistor's value, which tells us how much it resists the flow of electric current. Resistors work by providing a set amount of resistance to the electric current in a circuit. When current flows through the resistor, some of the energy is converted into heat. This controlled resistance allows other components, such as LEDs, microchips, and motors, to receive the right amount of current to function properly. Resistors are used in many everyday devices. In smartphones and computers, they help control the power in complex circuits. In remote controls, they regulate current to protect sensitive electronic parts. In TVs and radios, resistors control voltage and current, keeping the electronic parts running safely. Every resistor has a tolerance level, which tells us how precise the resistor's resistance value is. Tolerance is important because it shows how much the resistor's actual resistance could vary from its stated value. Tolerance is usually given as a percentage. For example, A resistor with a 5% tolerance might have a resistance value that is 5% higher or lower than its stated value. Resistors often use a color coding system to show both their resistance value and their tolerance. Each resistor has a series of colored rings painted on it, and each color represents a number or tolerance level. Here's how it all works. The first ring corresponds to the first digit of the resistor's value, while the second ring to the second digit of the resistor's value. Then the third ring is the multiplier. It shows how many zeros to add. Lastly, the fourth ring gives you the tolerance level in percentage. Let's make an example. A resistor with red, violet, brown, and gold rings would have a resistance of 270 ohms with a 5% tolerance. Each color corresponds to a number, making it easy to determine the resistor's value and tolerance quickly. This system helps engineers and technicians pick the right resistor for each circuit without needing additional equipment. To sum up, electrical resistance and resistors play an essential role in controlling the flow of current in electronic circuits. By understanding resistance, resistivity, and how resistors work, you can see how electronic devices remain safe and reliable. The color code on resistors and their tolerance levels also ensure that circuits get the correct amount of resistance they need, helping devices perform optimally.